Welcome to the Delacor Queued Message Handler Getting Started video. Once you have installed the Delacor QMH package, you will have access to the help. You can go to Help, Delacor DQMH Help. This will launch the documentation in your default browser. Most of the information that we're going to be going over this video is going to be in this document. There's also links at the end of the document for our support group and more videos like this one. The other place you can access this documentation is by going to Create a Project, and you'll see all the different templates there. The Delacor QMH is listed under All and also under Delacor. If you click on the link for more information, it will open the same documentation that I just showed you. We are going to create a project, our first project here, and we're going to call it Getting Started with DQMH. And we give you the option to either include or not include the DQMH events. These events are useful to explain how the DQMH works. However, probably when you're creating a new project for your application, you might not want to include them. Also, if you already have an existing project where you would like to add a Delacor QMH to it, you don't need to do it from this window. You can go to Tools, Delacor, DQMH, and you have the option to add a new DQMH module to an existing project, as well as creating an event or removing existing events from modules. We'll get to that later. Another thing that gets installed with the package is you can go to the Find Examples, and it comes with shipping examples. The shipping examples will be found under Fundamentals, Loops and Structures, and it is the DQMH Fundamentals Thermal Chamber project. Another way to find it is just by doing a search for DQMH. We hope we're going to be able to add other examples in the future. So if I double click on that, that will open the shipping example. You're going to notice that the shipping example project structure is very similar to the one that we created with the Getting Started. The difference is we have our testers here. The documentation that I already showed you is also available by the project that you created. And you have two DQMH modules, my Singleton module, my Cloneable module, as well as an application and its builder specification. The shipping example has also testers. It has a DQMH for the thermal chamber, which is equivalent to the my Singleton, and it has also a device under test that is clonable. It's equivalent to the Cloneable from the Getting Started project. Why did we do the unit under test clonable? Well, you might be having multiple units under test that are tested at the same time, where you only have one thermal chamber. So since you only have one thermal chamber, you're only going to want one window to represent it. The shipping examples also come with a test stand manager. Please do not fret if you don't have test stand installed, the examples will still run. For example, this machine doesn't have test stand included, so the sequences just don't have the test stand and don't do anything. If you're interested in how to combine test stand and DQMH, please watch the other video we have on the shipping examples for test stand. We also included on the shipping examples 3 simple examples of how to use the DQMH already package. We'll get to that in a minute. First, let's get clear some nomenclature. I'm going to move away the example for a little bit here, and let's go just to the project template. Let me open the documentation that I showed you earlier. The way the QMH works is it's a type of producer-consumer. You will have your event handling loop on the top, and it will be registered to listen to requests from other VIs. A request or request event is an event that is fired outside of my DQMH, and I am registered to listen to it via this wire here. So in this example, I have the My Singleton module receive the request to do something. So the message was received from outside of the VI, and then it gets in queued for the message handling loop, the consumer loop, to handle it. When we get the message, we consume the message, we dequeue it, and we go to the appropriate case in the case structure. In this case, the one that's going to be executing the do something event. Optionally, I can broadcast to the outside world, and anybody that is registered to listen will find out that I did something, or that the module, the Singleton module, did something. Some extra pieces are we manage the single instance module or the cloneable module in here, and at the end we clean up before we leave. The DQMH modules can be handled by themselves as a standalone or as being part of a larger application where they get called. As you already seen, we're going to be having a tester and a module. You will always see that even when we go to the tools, Delacor, DQMH, add new DQMH module, let's just put here my new module, and we'll choose it to be a singleton. You can choose whether you want singleton and cloneable, and also you can choose whether you want to include or not the do something events. In this case, we're not going to include it. You'll see that when the code is created, we're going to be getting a new module added to our modules folder, as well as a tester. They will always come together. This is because we find that the testers are useful to test the public API, the public application programming interface, how the other parts of your program are going to be communicating with our DQMH modules. And also, you'll see later, testers can be used as sniffers while your program is running. So I'm just clicking there to save, and that's always the case. We're going to have a module and a tester. Let's look at the different parts of the module. The MySingleton module will have, and you'll see, I mean, this code was created from scratch, right? We used the template to create this. All of these VIs are already given for you. You don't have to worry about them. The main interaction for the rest of your team, or even yourself when you're working with this code, is going to be the public API. You're going to have a set of requests. Again, requests are events that are generated from the outside world to ask my module to do something. In this case, the shipping example has the do something else, and wait for reply. Show panel, hide panel, stop, show diagram, and get module execution status. And the start, synchronize, and obtain events that we'll see in a minute. There's other things to the module, but let's say that you're working with a team with different levels of proficiency and you don't want to overwhelm them with all the details. You can go to the properties of this library and go to protection and lock it, and anything that's set as private is going to disappear. So the only things that really the outside world or other developers need to be aware of is the public API of your module. Okay, so let's get it back to not being protected. There we go. And you'll see that the main VI is here. The main VI has, like I showed you in the documentation, the event handling loop that is going to be receiving events that happen either from the front panel, find terminal here. So this case is to test that do something message when this VI is running along and is registered to listening to this button being pressed. Or you can register to events that come from the outside world that are the requests. Notice something. This is do something API method. That's the same VI as this. Okay? When a message is received, either from the front panel or from the outside world, it is enqueued to the message handling loop. The DQer then decides which case we're going to go to and then handles it. In our case, we're also including firing a broadcast event. A broadcast event is when our module wants to tell the outside world that something happened. Let's look at this in action. So if I run this module, this is another thing that we wanted to do. We wanted to make it possible for the modules to be run by themselves. So this could be all you do. This could be, for example, the control to the thermal chamber that we talked about earlier. I also want to be able to simulate errors. If I'm running in a standalone way, I want the program to stop and let me go back and try to troubleshoot what happened, right? We'll see later that when we are running with code that has called these from the outside, we won't stop. We'll let the calling code deal with the errors. Okay, so how do we simulate or exercise the public API? Well, that would be with the tester. Now the tester if I show you also on the documentation, we have a nice little diagram here. The tester is a very simple while loop with an event structure that registers to listen to the broadcast events. Remember, broadcast events were things that my module is telling the outside world that it is doing. And then when one of those events is received, like the I did something, the broadcast is received, and then I can indicate that through the front panel of the tester. And then at the end, we stop the DQMH main. So how does this look over here? So if I go to my test, my Singleton, I can say run, start my module, show the module. There he is again. And in this case, if I run an error, I just get the message on the calling code that there was an error, but my program doesn't stop. So you can see that this is beneficial while you're doing troubleshooting. Speaking of troubleshooting, I have a button to show the block diagram, so I can see how things happened. So let's say, for example, that I want to put a breakpoint right when I received the do something message. So let's look at that. I'm going to click on the test do something on my tester. The tester, if you look at its block diagram, what it did is, where is the do something? Here it is. Value change. My Singleton module tester sent do something. That's the message that I sent to the do something. This is on my tester. If I go to the Singleton module, you'll see that exactly the message that I receive is my Singleton module tester sent do something. So magic, I have two different VIs communicating between each other. This in turn is going to enqueue the message to the message handling loop. That's going to be receiving the do something. As soon as I execute, you see, test my Singleton module tester sent do something. And then it is going to tell the outside world that we did something by using this other VI. So let's finish the execution, and you'll see my Singleton module tester sent do something. This is how we complete the loop. Okay, so let's bring this to an actual, real life example, and let me stop. Another thing is I can stop the module, restart it again, show it again, right? Stop the module. This is also useful because it means that you can go back and work on your main. Like, let's say you're in the middle of troubleshooting something, and then go back and test it again. All right? Okay. Let's stop that. And let's go to the other project, the one that we opened for the thermal chamber. So the thermal chamber, we said that the thermal chamber was the equivalent to the Singleton module, right? So let's look at it. It starts to look very similar. We do have the start module, synchronous module events obtained for registration, and we have our same requests, except obviously the thermal chamber doesn't have the do something or do something else. Instead, it has the update set point, update ramped rate, update heater state, chamber status, and request and return status. And it also comes with its tester. I can run the thermal chamber as a standalone module, where I can say, okay, I want to go to 30 degrees. That's my new set point. And if I enable the heater, it's going to start ramping up until it gets to the set point, right? I can then disable the heater if I don't want it to keep going. And I can stop the VI, and the VI is ready for me to run again. That's if I want to run it as a standalone. If I want to test it via the tester, I can run the tester, say start module, then show my module. There is my thermal chamber. And now I can decide to either I send the messages from the front panel directly, or I can send them via the tester. Right? And you saw that it received the message. I can change the rate that my ramp rate, and you receive the message. I can also choose to start the furnace heater from over here, from the tester, or stop it. And same as before, I can stop the module and restart it if I want, and show the module again. The refresh is going to be giving me the actual current reading. So you notice that the furnace temperature chart was not updating all the time. It only updates when I hit the refresh. All right, so the tester looks very similar to the tester that comes with the project template, right? It is also a simple while loop with event structure. And what was happening when I was changing, for example, the set point, I can go to find the terminal, and I am using this update set point VI. The update set point VI, what it's doing inside of it is basically getting the reference to an event and firing that event. Then, in turn, the main VI for the terminal chamber, it is registered to listen to those events. If you see here, if I open this VI, you'll see that the update set point is one of the events that I'm registered to listen to. So when I get that message, the terminal chamber controller request event update set point, I get my message and I send it to the update set point and update controls. And the message handling loop receives it on the update set point, sets the set point to the actual controller, and then sends the update to the update display that says that we updated the temperature. If we go to the case for the update display, you'll see that the status update is just a string that is saying which module sent the message and then fires the event status updated. And this is how we complete the circle. I go back to the tester, and the tester is showing the status here. And the way we do that is because we are registered for the status updated event that received the message and displayed it. All right? Okay. So I know this is a lot of information, and it's going to take a little while to playing back and forth with the testers in combination too with the modules. Now, the shipping examples also have this collection of 3 simple VIs. We wanted to show that once you build your code, once you get your DQMH going, you don't have to have a state machine or another QMH to call it. You can have the simple, train of VIs. You start your module. You always have to have the synchronization for the module events. And then you show the panel, send the message to update the set point, you update the ramp rate, and set the heater state to be enabled, so enable the heater. And then we start using this new type of event. This is the request and wait for reply that is requesting the actual temperature. The difference with the request and wait for reply is that instead of just firing the event, we are also adding as part of the argument a notifier. All right? So when the temperature chamber receives, the message called request and return status, so we go to the message request and return status, there it is. We go to the state request and return status. Here we reply and send the message back to the notifier. So our request, it stays there waiting for this reply. Why did we do that? Well, it's important because sometimes there are things that you want to be synchronous messages and not necessarily asynchronous messages. The request and broadcast pair is asynchronous. I send the request to the module responds whenever it wants, and then later on it will send a broadcast. But if I have something critical, like let's say I want, I'm working with radiation or something like that, and I need to have confirmation that the vial is closed before I keep going, that's a synchronous message. In that case, I don't want to wait for later for a broadcast message. So this is what we have here, is a request and wait for reply. And then when we're done, as soon as the actual temperature reaches the set point, the VI will stop and will stop the module. So if I run this VI, you'll see that the thermal chamber started because I showed the panel. I set the set point to 75, there it is. The ramp rate to 10, there it is. The heater is enabled, and we are getting the temperature, and as soon as we hit the set point, it stopped. Okay? The next example is the thermal chamber controller with DUT. So same idea, we have the same from the first example, but now we're adding a starting clonable modules. And in this case, we're just starting a single instance of the clonable module. We show its panel, we turn it on, perform self-test. We're just simulating some time here just so you get to see the result. And then we turn it off. So if I run this guy, it's gonna do the same thing that we saw before, going all the way to 75. And then as soon as it hits, our friend over here is going to show the panel for the device under test. So there is our device under test. It has been powered on. It did pass the self-test, and we stop. And the whole idea of the clonable modules was that we could have multiple clonable modules. So in this case, we go back to what you already seen in the first example, and we complicated a little bit the second one by starting the number of modules that I request on the front panel, showing all the front panels, starting them, performing the self-test, and then powering them off and terminating them. So if I run this, again, I'm going to have my thermal chamber hit the set point, and now we're going to get the different messages, the different clones started. So I ask for 5, so there's 1, 2, 3, 4, and the 5th one, and then they all did the self-test, and in this case they all passed. We have it set the failure rate to about 80%, so it's luck of the draw if you get it to see fail or not. And the device under test, again, we have it here on the main. It can also be run as a standalone, and I can do the self-test several times here, and eventually 80% chance that one of them is going to fail, and there you go, finally it failed. Right, and the difference with the between a clonable and a singleton module is really going to reside on the module admin and the fact that we have now to decide if the message is sent to this module or not. So you're going to have extra BIs here to handle the different clones. You can see that in more detail. So I think we're done with the example for now, so let me close these guys. And you can see that on the project that we created with the DQMH, that the My Cloneable module has an extra code here for module instances. And the tester looks a little bit different, as well as the main. So the main looks very similar to the singleton, and it can also be run by itself. Like we saw, if I do something, I get to do something else. I can also simulate errors, and it will also stop here. The tester lets me run multiple instances and gives me a list of all the modules that are available. And I can select whether I send a message to all of them or just some of them. So if I say, okay, I want to send a message to all of them and show all the module panels, I'm going to get them all here, right? If I want to send the message to all of them, there's a do something, there's a do something else, and finally we also have the something else and wait for reply. So if let's say I want to send the message only to number 5, I can go here to number 5 and say I want to send something and wait for reply. And what it simulated is it got the number 3 that I sent, and then it added a random message. But you can see that none of the other clones has that message. So the message was only sent to number 5. If I had instead sent it to all and say wait for reply, I eventually get the reply from all of them, right here on the status. All right. I can choose to stop them individually or stop them all at a time. So the only main difference is going to be that we have always this information about which is the clone that I'm communicating with. And like I said, on the clone itself, when it gets an event, it's going to have to decide if the event is addressed to it or not. All right? Okay. So I know that you're probably getting really tired, but let me finally show you. I already showed you that I can create a new module to an existing project by going to Tools, Delacor, DQMH, add new module. I can also create new events. So you really don't have to worry about all the creation of user events. You can say, I want to create a new event. What this is going to show you is the different DQMH modules that you have available in your project. So I can choose, for example, on the my new module, I can add a request, and here's the description of what a request is. It's again the outside world requesting something from my module. A broadcast, this is the module telling the outside world that something happened. There's the request and wait for reply. This is the one where I give the notifier as part of the argument and we wait until the reply is received, and it's useful when you want to send synchronous messages. And then we have the round trip, the request plus broadcast. This is just to make it easy. We found that throughout the use of these tools that we were most of the time, every time we created a request, we also created a broadcast, like the "Hey, do something," "Yes, I did something." So it's just to facilitate things. So if I wanted to do, for example, get name request, so it's please give me your name, and then when the module is done, it broadcasts and says name updated. The get name probably really didn't need the argument, but it's just it saves me one step. So let's, yeah, I don't want virus protection for now. So let's take the string and put here name. See, so let's just put module name. This is going to be the argument. All right. So when I click, oh, and I also have the option of entering a description. So in this case, I could say get name asks for my new module to give its name. Name updated sends the all broadcasts my new module name. And I'm going to say OK. So what this is going to do is going to be creating on the project. It created, and it highlights here, that it created the request get name under my new module. It also opened several windows, and it also created the broadcast under broadcast for name updated. My code is broken now, and I have now an option to know what is it that I need to do, because I have this list of code needed. So in this example here, it says configure this event frame for the name updated broadcast event. So I'm going to right click, edit events handled by this case, and I know that I'm communicating to my new module, and the instruction said that I want to update the name updated. So I'm going to select that, and I need to decide now what is it that I want to do with this data. So I'm just going to create an indicator for now and just put it there on the top. There you go. Okay, it's still broken, so I'm going to go and show the error, and it added for me the request that I created, and my request was to get a name. Now if I know that already that I'm never really going to be providing a name for the request, I can just come here and change this as a constant. A lot of people have asked, why is it that we force you to create an argument? And the reason for that is we try to make things easy to maintain, and by having already a placeholder for the type def means that if later on you change your mind and you do want to add an argument, you only have to open the type def, add the new elements of the argument, and the events and everything else is going to update automatically, so you don't have to worry about that. That's why we force you to create one. Okay, so my instruction says assign this event frame to a new front panel control used to test the get name request event. So I'm going to add a button here for get name, and find a terminal, and we're going to add it here. Edit events handled by this case. Let's register for the get name value change, and I no longer have a broken arrow. Of course, if I run this now, nothing is going to work because I haven't done anything on the main. So the main's still broken, and it was also open for me when we created the events. So I'm going to see, okay, again, my code needed is already open in the cases that I need to work on, and it says configure this event frame for the get name request event. So I'm going to edit the events handled by this case, go to my new module, register for get name, and here it is, the module name. That's what I gave it as a name. And then these created the enqueue of the message get name, and it also created the case get name on the message handling loop. So all I need to do now, if I had information, I could process it here. It also just say whatever is it that you want to do when you get the name. It had also created outside here my broadcast. So I'm going to bring the broadcast, and it says basically drop this BAI wherever you need the broadcast, the name updated. So I'm going to delete that guy. And one of the other private BIs that we include with the DQMH module is a module name constant. So I just need to find the one for my module, my new module. There it is. And I'm going to put it there. And that's the argument that I'm going to send. Okay. So, and this module name, all it is it gives you a constant for the name. So if I wanted to put here hello DQMH world and make it, this is the name now of the module, because that's what I wanted to say, I'm gonna and I can see that this still works as a standalone, and now because I gave that the name, now the name of the singleton is hello DQMH world. All right, so we're gonna close that, and we're gonna run it and do start module, show module panel, get name, and I get the name up here. One of the other things I was going to point out, if I stop the module and I click any of these buttons, I'm going to get an error. That's expected. We want the tester not only to test when things work, but also how things can fail. And we want to make sure that we can test that we get that error back when we request something of a module that's not running. So I hope you enjoyed this demo. There's a lot more to it, of course, and please, send your questions to the support group. Like I said, the way to get there is you can go to help, Delacor, DQMH help. There's enough information here, some of the stuff that I had already mentioned, and if you go to the belly button, you can find the link to the support group and some more videos like this one. If there's anything else you want to see on the videos, please let us know, and we'll add a video for that. Thank you.